Hello everyone, and today we are going to be covering our last section of the measurement and conversion unit, and this is all about putting numbers in perspective, just looking at scientific notation. Now this should be review because at some point we always have scientific notation in one of our math courses, but I do want to review just to make sure, because if it's been a while, it's kind of like riding a bike, you eventually recall it. Scientific notation is a format in which a number is expressed as a number between 1 and 10 multiplied by a power of 10. Basically, this is how I like to put it. It's a great way to take really, really large numbers or very, very small numbers and write them into what we call scientific notation to make it just for simplification. Let me just show you the chart that we have here. What you do when you want to turn a number into scientific notation, so you can see on the right-hand side, these are all numbers that are now in what we call scientific notation. You always want to make sure that your decimal, let me see if I can just switch the color. Okay. You want the decimal to be between the ones place and the tenths, meaning when we turn this into scientific notation, my decimal would go right here. So I have just the ones unit on the left. Then, and so notice over here we wrote 5.2314. Now to know how many, to what power are you putting to the 10th power, you count how many decimal places you have to move to get to the end. So I'd have to go 1, 2, 3, 4. I'd have to move 4 places, and that's where we get 10 to the 4th. Now notice this one. This is 3.2. That's already written. You can't move this decimal anymore. So if you were to write that in scientific notation, you would actually say 3.2 times 10 to the 0, because I'm not moving any place to the right or left. It's already written in the form that we need it. Same thing with number 3. We would start here, right? So I need to have the ones right here, so 4.28. But if I move, I'm going 1, 2, 3, 4, 5. I went 5 places to the left, and so to the left means I use a negative decimal. Essentially, the positive, not decimal, sorry, negative power, the positive power lets us know we're moving to the right, and the negative will let me know we're moving to the left. Typically, when I see a negative exponent for scientific notation, I know that the number we're looking at is a small or very small number. That's basically the rules. And so let's try some of these and see how we do. We want to write these either the number, the standard number in standard form, or we're going to write it in scientific notation. Now notice this one. It says what number is 2.3 times 10 to the 5th. Okay, so I start off with 2.3. The 5 tells me I'm moving to the right 5. 1, 2, 3, 4, 5. So the number that we're actually looking at here would be, and I'll just write it out neater, 230,000. Number 2. What number is 1.6 times 10 to the negative 2? I start off writing my number. The negative 2 tells me I'm going to move to the left 2 decimal places. So 1, 2. That's where my 0 goes. Cleaning this up, my number would be 0.016. Number 3, the total spending in the 2020 federal budget was 6.5. Look at all those zeros. Yeah, that's a lot, right? Let's turn this back into scientific notation. So I know it's going to be 6.5 times 10 to something. But what I'm going to have to do is a lot of counting. So I'm starting here, because remember, this is where I'm putting the decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I had to move 12, and that means that my number in scientific notation would be 6.5 times 10 to the 12th. So $6.5 trillion. All right, last one. The diameter of a hydrogen nucleus is that tiny, tiny number. We want to put this in terms of scientific notation. Well, the end is a 1. Okay, that's where my decimal would go because we want to have the ones place. Now you could put 1.0 times 10 to the power, or you could just say 1 times 10 to the power. That is up to you. But now we have a lot of counting to get to the end, right? So we're going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I had to go to the left, 15. That would be to the negative 15 power. And that essentially is scientific notation. Thank you.